We are at the beginning of a new industrial revolution. In the past, industrial revolutions were defined by the harnessing of energy to augment human muscle. We took coal and water and created steam. We took electricity and powered the world. But this revolution is different. This is a revolution of intelligence. We are now harnessing data to augment the human mind at a scale that was previously inconceivable. For the last 60 years, the world of computing has been defined by one central idea, the CPU. We followed the path of general-purpose computing, where we wrote software line by line, telling the computer exactly what to do. We relied on the miracle of Moore's law to make those lines of code run faster every 18 months without us having to change a thing. It was a wonderful era. It was a free lunch. That era is over. The physics of the transistor have hit a wall. You cannot simply shrink things forever and expect the same gains in performance and energy efficiency. As Moore's law slowed to a crawl, the demand for computation exploded. We are asking computers to do things today that were science fiction just a decade ago. Understanding natural language, simulating the biology of a cell, predicting the climate of the entire planet. If we had stayed on the path of traditional, general-purpose computing, the cost of these advancements would have been unsustainable. We would have run out of power, we would have run out of money, and we would have run out of time. This is why I say, software is dead. When I say software is dead, I am not saying that we will stop using computers. Quite the opposite. I am saying that the method by which we create the digital world has fundamentally changed. For half a century, software meant a human being writing a set of deterministic instructions, if-then-else, loops, and logic. It was a process of translation where we tried to speak the language of the machine to get it to do our bidding. That was software 1.0. It was limited by human cognitive bandwidth. We could only write what we could conceive. We have now entered the era of the intelligence factory. In this new era, we don't write software, we train models. We provide the data, we define the objective, and the machine learns the pattern. It creates its own internal logic, a logic so complex and high-dimensional that no human could ever write it. This is software 2.0. It is generative, it is autonomous, and it is the foundation of the AI revolution. To power this revolution, we had to go back to first principles. When you hit a wall in physics, you don't just try to hit it harder, you find a different way. At NVIDIA, we realized 30 years ago that for certain types of problems, the most important problems, the serial processing of a CPU was the wrong architecture. We needed massive parallelism. We needed to do thousands, millions of things at the same time. This was the birth of accelerated computing. But our journey was not a straight line to success. People see the NVIDIA of today and they think it was an inevitable triumph. They see the Blackwell chips and the trillion-dollar valuation, and they assume we always knew exactly where we were going. They don't see the struggle. They don't see the moments where we were exactly 30 days away from bankruptcy. I remember the era of the Riva 128. We had failed with our first architecture. We had spent almost all our capital. We were a tiny company in a world of giants like Intel and SGI. We were staring at the end of our company. In that moment of near death, we had to be incredibly humble. We had to admit that our first approach was a mistake. We had to pivot. We had to ask for help from our partners. That humility, that willingness to admit failure and adapt with desperate urgency is the soul of this company. I often tell students that I wish them enough pain and suffering. I don't say it because I am mean. I say it because resilience is the most important trait for an innovator. You cannot build the future if you cannot survive the present. Character is not formed in the sun. It is forged in the fire of failure. At NVIDIA, we act as if we are 30 days from going out of business every single day. Not because we are afraid, but because that urgency keeps us focused on the first principles. It keeps us from getting comfortable. It keeps us from becoming a software company in the old stagnant sense of the word. To lead in this new era, we had to rethink how a company even functions. Most companies are built like a hierarchy, a pyramid where information is filtered as it moves up. I hate that. We have a very flat structure. I don't do one-on-ones because one-on-ones are silos. If I have something important to say, I say it to everyone. I want the ground truth to travel at the speed of light. In a flat organization, you don't lead by authority. You lead by the clarity of your ideas. You lead by being the person who can see the physics of the problem first. And the physics of the problem today tell us that the data center is no longer a place where you store files. The data center is now an intelligence factory. Think about an old world factory. You take in raw materials, iron ore, coal, and you use energy to turn them into something of value, like steel or a car. An intelligence factory does the same thing. The raw material is data. The energy is electricity provided by our GPUs, and the output is tokens of intelligence. These tokens can be a word in a sentence, a pixel in a video, or a movement in a robotic arm. This is a fundamental shift in the global economy. For the first time, we have a factory that produces a commodity that is weightless, infinitely scalable, and universally applicable. Intelligence is now a manufactured product, and just like the steam engine and the power plant, the intelligence factory will be embedded in every industry on Earth. Every company will have an AI factory. Every country will have sovereign AI. We are moving from a world of retrieval, where you click on an app and it fetches a file from a server, to a world of generation. When you ask a question to an AI, it isn't finding the answer in a database. It is inferring the answer. It is creating the answer in real time. This is the death of traditional software architecture. The era of the app is being replaced by the era of the agent. But to make these factories work, we had to solve the impossible problem of energy and scale. This is where the transition from the CPU to accelerated computing becomes a moral imperative. If we tried to build the world's AI models using only CPUs, we would have to pave the planet in silicon and burn every forest for power. By using accelerated computing, we have reduced the cost and energy required for intelligence by a factor of 1,000. We are making intelligence so cheap and so abundant that it will be a human right. I see people waiting. I see people wondering if they should wait and see where the AI goes. Let me tell you, run, don't walk. The speed of this transition is unlike anything we have ever seen. The time between a breakthrough in a lab and a product in the market has shrunk to months. If you are not reinventing yourself today, you are already obsolete. This is not just a change in technology. It is a change in the very nature of work. People ask me, Jensen, what should I study? Should I learn to code? And I tell them, no, don't learn to code. The computer already knows how to code. We have spent 60 years trying to make computers understand us. Now they finally do. The programming language of the future is natural language. If you can speak, you can program. The real skill of the future is not syntax, it is domain expertise. If you are a biologist, be the best biologist. If you are a farmer, be the best farmer. If you are an accountant, be the best accountant. The AI will provide the technical software layer. You must provide the first principles of your domain. You must be the one who knows what problems are worth solving. At NVIDIA, our job is to provide the acceleration engine for your vision. We build the Blackwell architecture, the most complex piece of technology ever created by human beings. It is a system designed to be the heart of the intelligence factory. It is not just a chip, it is a complete stack of hardware and software that allows you to train models that were impossible yesterday. But even with the most powerful tools in the world, you still need the resilience to fail. We have built things that nobody wanted. We have invested billions in $0 billion markets that didn't exist when we started. We did it because the physics told us it was the right path. We did it because we were willing to suffer for a decade before the world caught up. The work of your life is not a job description. It is the thing you build that didn't exist before. It is the contribution you make that changes the trajectory of your field. To do that work, you have to be willing to be misunderstood for a long time. You have to be willing to be the person who is cleaning the toilets at the tech world's version of Denny's, doing the unglamorous work that builds the foundation for greatness. When I was a dishwasher, I was the best dishwasher they ever had. I didn't see it as a low job. I saw it as a job that needed to be done with excellence. I brought that same mentality to NVIDIA. Whether we are designing a transistor or a data center, we do it with the same intensity. We don't do it because it's profitable. We do it because it's hard and because nobody else can do it. That is the essence of the intelligence factory. It is the culmination of everything we have learned about physics, silicon, and human creativity. It is the engine that will allow us to solve the impossible problems of our time, curing diseases, solving the energy crisis, and understanding the mysteries of the universe. But we must move now. The transition from software 1.0 to the AI factory is happening in real time. It is a race, not a race against each other, but a race against the limits of our own imagination. That imagination is now the only constraint. In the era of the AI factory, the bottleneck is no longer the speed at which we can write code, but the clarity with which we can define a problem. For 60 years, we were limited by the how. We spent all our energy trying to figure out the syntax, the compilers, and the specific instructions to give a machine. We were like architects who had to spend 80% of our time carving every single brick by hand instead of designing the cathedral. But now, the bricks are carving themselves. The AI is the ultimate craftsman. This means your value as a leader, as an engineer, and as a human being has shifted from the labor of execution to the brilliance of intention. This shift is the reason why the traditional discipline of computer science, as a narrow vertical of coding, is nearing its end. But it is also the reason why the era of human empowerment is just beginning. We are moving from an era of specification to an era of vision. When the machine is human literate, when it can understand your language and the laws of physics, the most valuable skill you can possess is domain expertise. If you want to solve the mysteries of the human heart, you don't need to be a C++ expert. You need to be a cardiologist who understands the first principles of hemodynamics. If you want to design a new type of sustainable aircraft, you don't need to be a Python specialist. You need to be an aerospace engineer who knows how to use the AI factory to simulate 1 million different wing configurations in a digital twin. The coding part, the translation of your idea into a machine-readable format, is a solved problem. It has been automated by the very intelligence we are manufacturing. To facilitate this, we had to develop a very specific architecture at NVIDIA. We call it the three-computer strategy. It is the blueprint for the physical AI revolution. The first computer is the AI factory itself, the massive training system where we feed the world's knowledge into a neural network. This is where the AI learns to reason, to speak, and to predict. The second computer is the omniverse, the digital twin of the world. This is where the AI goes to practice. You cannot train a robot in the real world. If you want a robot to learn how to navigate a busy warehouse, and it takes 10,000 failures to learn, you can't have 10,000 real-world crashes. It's too expensive, too dangerous, and too slow. But in the Omniverse, we can run 10,000 simulations in a second. We can simulate gravity, friction, light, and mass with high fidelity. The AI lives 1,000 lifetimes in the digital realm so that when we finally put it into a physical body, it wakes up already, knowing how to work. The third computer is the edge computer, the robot brain that lives inside the car, the drone, or the humanoid. This is the computer that performs inference. It takes the intelligence manufactured in the factory and the experience gained in the Omniverse and applies it to the real world in real time. This three-computer loop is the engine of the next trillion-dollar industry, and it is a perfect example of first principles thinking. We didn't look at what other people were doing with robotics. We looked at what the physics of the problem required. We realized that for an AI to interact with the physical world, it needs a physical world to learn in. That didn't exist, so we built it. We built the Omniverse when everyone else was talking about social media metaverses. We built it for the engineers. We built it for the robots. We built it because the future demanded it. Working on things that don't exist yet is a lonely process. It requires a level of strategic patience that most people don't have. When we were working on accelerated computing for science and AI, the stock market didn't understand it. Our competitors didn't understand it. There were years where the growth was flat, where the skepticism was high, and where the pressure to return to traditional computing was immense. But we stayed the course. We stayed the course because the physics were irrefutable. We knew that general-purpose computing had hit a wall. We knew that the demand for intelligence would eventually exceed the supply of the old architecture. If your first principles are correct, you don't need a roadmap from someone else. You are the one drawing the map. This brings me back to the importance of our organizational structure. To maintain this level of innovation, you have to kill the bureaucracy of management. In a traditional company, an idea has to go through 5 layers of approval before it gets to the CEO. By then, the idea has been sanitized and the urgency has been lost. I don't want to be managed, and I don't want to manage others. I want to lead. That's why NVIDIA is flat. That's why I don't have a corner office. I want to be in the cafeteria with the people who are actually building the chips. I want to hear the ground truth of the problem. If we have a failure, and we have many, I want to know about it immediately. I want the humility to admit when a project isn't working so we can pivot before the 30-day clock runs out. We treat every success as a temporary state and every failure as a permanent lesson. This is how you build a company that lasts 30 years and remains a startup at its soul. We are now seeing the rise of sovereign AI. This is the realization by nations that their data is their most precious resource. In the past, countries exported their raw data to have it turned into intelligence elsewhere, and then they had to buy that intelligence back. That is the old colonial model. In the new era, every country will have its own AI factory. They will take their own language, their own culture, their own legal and medical data, and they will turn it into sovereign intelligence. This is the democratization of power. It means that the next great breakthrough in oncology doesn't have to come from Silicon Valley. It can come from a researcher in Colombia who has the domain expertise and access to a local AI factory. The end of computer science is not a retreat into the past. It is an explosion into the future. It is the moment where the digital and the physical become one, when you can describe a new material in natural language and the AI simulates its properties in the omniverse, and then a robot in an automated factory builds it for you. That is the ultimate realization of the human will. We are finally moving at the speed of thought, but this speed requires a different kind of character. It requires you to be urgent. I see so many people waiting for the perfect time to start. They wait for the market to be ready. They wait for the technology to be mature. Let me tell you, if the technology is mature, the opportunity is gone. If the market is ready, you are already a follower. The opportunity is in the fog. The opportunity is in the $0 billion market. You have to be willing to run even when you can't see the finish line. You have to be willing to suffer through the early days of a new technology when nothing works and everyone thinks you are crazy. That suffering is the price of admission for building the future. At NVIDIA, we are building the Blackwell architecture to be the engine of the human spirit. It is the most complex system ever designed, but its purpose is simple: to make intelligence cheap, abundant, and accessible to everyone. We want to reduce the cost of discovery. We want to reduce the cost of creation. We want to empower the next generation of leaders to solve the problems that my generation couldn't. We are entering a world of physical AI where everything that moves will be intelligent. We are entering a world of digital biology where disease is a technical problem to be patched. We are entering a world of AI factories where intelligence is manufactured as a commodity. This is not a distant future. This is the world we are building today, chip by chip, token by token. The transition from the CPU to accelerated computing is the most significant event in the history of technology. It is a fundamental shift in the soul of the machine. We are no longer building tools that we use. We are building partners that think with us. As we look toward this horizon, I want you to remember that the most important part of this entire revolution is not the silicon. It is the person. It is you. The AI doesn't have a vision. The AI doesn't have a mission. The AI doesn't know what is worth suffering for. Only you do. The intelligence factory is online. The omniverse is ready. The robot brains are shipping. The tools of the gods are on your desk. The only question is, what are you going to lead? What is the impossible problem you are going to solve? Don't wait for a permission slip. Don't wait for a manual. There are no manuals for the future. You have to go out there and write the first chapter yourself. You have to be willing to be the dishwasher, the busboy, and the CEO all at the same time. You have to maintain the humility to learn and the grit to survive. The world is moving fast. The intelligence revolution is here. It is the most extraordinary time to be alive, to be an engineer, and to be a leader. We are finally speaking the language of the universe, and the universe is listening. The conclusion is logically irrefutable. If intelligence is the foundation of all progress, and we have finally learned how to manufacture it, then there is no limit to what humanity can achieve. We have broken the chains of the CPU. We have entered the era of the AI factory. The work of your life is waiting for you. Run, don't walk toward your vision. Run, don't walk toward the next era of humanity.